In this lesson, we will cover what is a routing protocol. Routing protocol is a term for a set of protocols that determine the path that data flows in order to travel across multiple networks from its source to its destination. Routing protocols enable routers to build up a forwarding table that correlates final destinations with next hop addresses. A router uses its forwarding table to determine the next hop for the packet's destination and forwards the packet appropriately. The next router then repeats this process using its own forwarding table, and so on until the packet reaches its destination. Each router needs to have a view of the entire network to determine the best path to the destination. There are multiple types of routing protocols available today, but first we're going to look at the manual process of adding routes to a router, and that is called static routing. Now, to hop back into routing protocols, the first routing protocol that we're going to look at is called the distance vector routing protocol. A distance vector routing protocol makes a decision based on hop counts. It's very slow to converge, and it is not used often in today's networks. An example of one of these routing protocols would be the RIP routing protocol. The second, more advanced routing protocol is one called a link state protocol. This protocol actually builds a tree topology and uses link cost to determine the best route. This routing protocol is fast to converge and is very popular in today's networks. An example of this routing protocol is OSPF or ISIS. On this slide, we will walk through several examples of different routing protocols. The first routing protocol we're going to examine is one called the Routing Information Protocol, or RIP. RIP is an open standard and is one of the earlier routing protocols, but is not scalable for large networks and is only used in smaller networks and truthfully is not used that often in today's networks. The second routing protocol we're going to take a look at is OSPF, or Open Shortest Path First. OSPF is an open standard and is very scalable for large networks. We see this routing protocol used often in today's networks. Another example of a routing protocol would be one called Enhanced Interior Gateway Routing Protocol, or EIGRP, and until recently was Cisco proprietary. It is very scalable and easy to use and widely deployed across many networks. The final routing protocol we're going to talk about is Border Gateway Protocol, or BGP. BGP is an open standard and it is very scalable for large networks. It is used mainly today by internet service providers to share routing information between domains. BGP is outside of the scope for this lesson, but we wanted to make sure that you were familiar with the term. Here we're going to show the difference between a distance vector protocol and a link state protocol. If router A wanted to send a packet to router C with a distance vector protocol, we would be measuring the number of hops to our destination and making a decision based on that number of hops. In this scenario, the distance vector protocol would prefer to send packets from router A to router B and from router B to router C. This is because it is only 2 hops from router A to router C, and that is the metric that distance vector protocols use to choose the best path, even though if we take a look at the bandwidth that is available, it would seem that router A to D to E to C would be the better path due to the fact that DS3s and 10 meg connections are much faster than T1 connections. If we look at our link state protocol, we would see that it has chosen the correct path in this scenario. The link state protocol takes other metrics, such as path cost, into account when choosing its path, and in this scenario has determined that the multiple DS3s and 10 meg link is a much better path choice due to the increased bandwidth than router B. So in this case, you can see that a link state protocol in this scenario is highly preferred over a distance vector protocol. Please join me for the next lesson, Understanding the Routing Process.